This time, we want to tell you an incredible story featuring a single star. A tiny light in the vastness of the cosmos that forever changed our understanding of the universe. Its name? V1. A name that might seem insignificant, yet observing this star among billions of others allowed astronomers to discover that the universe is far larger than anyone had ever imagined. And this had extraordinary implications, not just for science but for our perception of existence itself. A century ago, our understanding of the universe was quite limited. Astronomers believed that our galaxy, the Milky Way, was the only one in existence and that it contained all the stars in the universe. The sky, though infinite, was thought to be a stretch of lights shining within a solitary galaxy. However, mysterious objects challenged this belief. Enormous nebulas and clouds of matter, whose true nature remained a mystery. Some thought they were mere clusters of gas and dust, but no one had ever attempted to truly measure their distance. In 1923, a young astronomer named Edwin Hubble began studying one of these nebulas through the most powerful telescope in the world, located at the Mount Wilson Observatory in California. This was the Andromeda Nebula, one of the brightest and most mysterious objects in the sky. Hubble was drawn to a single variable star within this nebula, the star V1. That star would provide the key to measuring Andromeda's distance and uncovering the true nature of this mysterious object. The results of his observations were astonishing. V1, a type of star known as a Cepheid variable, not only proved crucial for calculating Andromeda's distance but also revealed that this nebula was far too distant to be part of our galaxy. It was not a simple cloud of gas, as many had thought, but an independent galaxy, just like ours. Suddenly, the universe became much larger than we had ever imagined. A small star, seemingly insignificant, had changed our perception of the cosmos. To grasp the significance of this discovery, we need to take a step back and talk about Cepheid variables, a particular type of pulsating star. In 1908, astronomer Henrietta Swan Leavitt, working at the Harvard Observatory, made a discovery that would become fundamental to cosmic measurements. Studying over 1,000 variable stars in the Small Magellanic Cloud, Leavitt noticed a surprising relationship between the stars' pulsation periods and their intrinsic brightness. Cepheids pulsate regularly, with cycles that vary according to their luminosity. The longer the pulsation period, the brighter the star. This discovery, known as the period luminosity law, transformed Cepheids into a cosmic ruler that astronomers could use to measure distances in the universe. Essentially, once the pulsation period of a Cepheid is known, its intrinsic brightness can be calculated. By comparing this brightness with the observed brightness from Earth, the star's distance from our galaxy could be determined. Now, back to 1923. At the time, the world's most powerful telescope was at Mount Wilson, and it was there that Hubble began meticulously studying the Andromeda Nebula. Despite unfavorable atmospheric conditions, Hubble devoted hours to his work. Between October 5 and 6 of that year, he managed to capture a long photographic exposure showing what appeared to be a nova, a star that suddenly becomes much brighter. Hubble marked the letter N next to the object on the photographic plate. However, in the following days, as he compared his images with earlier ones stored at the Mount Wilson Observatory, Hubble realized that what he had observed was not a nova but something far more intriguing. It was a Cepheid, a variable star that pulsated regularly. Its significance was enormous. This star would become the starting point for accurately measuring the distance to the Andromeda Nebula. In his excitement, Hubble erased the N and wrote var to indicate it was a variable star. After studying the Cepheid, he discovered it had a pulsation period of about 31 days. This relatively long period indicated that the star was extremely bright. If it was so bright yet appeared so dim from Earth, it had to be at an immense distance. The Andromeda Nebula, therefore, could not be part of our galaxy but had to be an independent galaxy similar to ours. Using Henrietta Leavitt's period luminosity law, Hubble estimated that Andromeda was about 1 million light-years away, an immense distance that seemed inconceivable at the time. Today, we know the actual distance is about 2.5 million light-years, but Hubble's value was already astonishing. This meant that Andromeda was not a nebula but a galaxy in its own right. Hubble's discovery radically changed our view of the universe, proving that there were other galaxies beyond the Milky Way. In February 1924, Hubble wrote a letter to astronomer Harlow Shapley, a staunch supporter of the idea that the Milky Way was the only galaxy in the universe. Shapley, upon reading Hubble's observations, was shocked. "This is the letter that destroyed my universe," he said. Indeed, that letter marked the beginning of a revolution. In the following months, Hubble discovered other Cepheids in Andromeda and other galaxies, confirming that the universe was far larger than anyone had ever thought. In December of that year, Hubble presented his findings at a scientific conference. His paper, titled On the Extragalactic Nature of Spiral Nebulae, was met with enthusiasm and won the prize for the best presentation. But more importantly, his observations had demonstrated the existence of galaxies beyond our own and that the universe was much vaster than we had ever imagined. Hubble's discoveries also marked the beginning of a new era in astronomy. From then on, observations of galaxies multiplied, and in 1929, Hubble formulated the Hubble law, which established a relationship between a galaxy's distance and its velocity of recession. This law provided evidence that the universe was expanding, a concept that became the foundation of modern cosmology. Today, star V1 continues to shine in the Andromeda Galaxy, and in 2010, the Hubble Space Telescope was pointed at it to celebrate its importance in the history of astronomy. Its light, which traveled millions of years to reach our eyes, symbolizes how a single, tiny detail can hold immense secrets about our universe. The story of V1 reminds us that even a small bright dot on a photographic plate, an object seemingly insignificant, can conceal the deepest mysteries. And sometimes, all it takes is a fresh perspective to discover that the universe is bigger, more complex, and more fascinating than we ever imagined. Thank you for watching. Leave a like, subscribe to the channel, and activate the bell to ensure you don't miss our next videos.